Hidden inside all of us are the secrets of our deep ancestry, stories that only DNA could tell. Printed on our genes are the origins of our lineages.
In 1799, George Washington died without a son, leaving behind a nation, yet no direct bloodline. For over 200 years, his genetic past was sealed in silence. But in 2024, science unearthed a forgotten trail through bones, graves, and a living man, revealing a lineage far older than America itself. Mystery that haunted a nation. George Washington's name echoes through history as the father of a nation, but not of a family. Though he helped birth the United States, he left no biological children behind. After marrying Martha Custis in 1759, Washington raised her 2 children from a previous marriage as his own. Yet the couple never produced a child together. Scholars have long speculated about the cause. Some suspect the smallpox that struck Washington in his youth left him sterile. Others propose a congenital issue, but in truth, no definitive medical record has ever explained this missing legacy. When he died at Mount Vernon in 1799, his personal bloodline died with him. For over 2 centuries, that fact clouded any attempt to trace Washington's ancestry through modern genetics. While countless historical figures have been linked to ancient roots through DNA, Vikings, pharaohs, emperors, America's founding father remained genetically anonymous. Without a son, there was no direct Y-chromosome to examine. Passed from father to son with minimal change over generations, the Y-chromosome is a living historical record, but only if that record remains unbroken. In Washington's case, the trail ended in silence. This dead end frustrated not just historians, but scientists eager to test how far back America's lineage could reach. Could his paternal ancestry trace to Anglo-Saxon nobles? Or perhaps to some forgotten migration through Europe's tribal past? For over 200 years, the answer remained locked away, hidden in the soil, sealed in the bones of the past. Chasing ghosts through paper and stone. Before DNA could enter the story, the only tools available to researchers were paper records and fading stones. For much of the 19th and 20th centuries, genealogists combed through marriage licenses, land deeds, colonial census rolls, and family Bibles to piece together the Washington family tree. These documents offered fragments of a legacy, but they lacked the resolution to answer the question that mattered most. Where did George Washington truly come from? Historians had long suspected that the Washington family had English roots, but vague references to relatives and regional migrations made it difficult to determine whether that origin was noble, common, or something altogether forgotten. The tantalizing possibility that America's most iconic figure might descend from medieval knights or Romanized Britons added to the mystery. Yet, with no biological descendants to test, the mystery remained stuck in the realm of speculation. But in 1999, a sliver of opportunity surfaced. A quiet excavation took place at the Harewood Family Cemetery in Charlestown, West Virginia. There, researchers sought the graves of Samuel Washington, George's younger brother, and his descendants. Archaeologists uncovered 5 unmarked graves. From 3 of them, they retrieved bone fragments and teeth, sealed inside sterile containers and carefully stored for future analysis. At the time, the science simply wasn't ready. The remains were too degraded, the technology too primitive. DNA extraction from centuries-old bone was still more hope than process. The samples were shelved for 25 years, their secrets suspended in stasis. But their moment would come. All that was needed was time and one unexpected breakthrough: the DNA that waited 25 years. For 25 years, the fragile bone fragments excavated from the Harewood Cemetery remained untouched in storage, sealed away like a time capsule beneath layers of dust and forgotten possibility. In 1999, the hope of extracting DNA from centuries-old remains had been more aspiration than science. But in 2024, that changed. The breakthrough came not from a university lab or a history department, but from the Armed Forces Medical Examiner System, specifically its Forensic DNA Lab, AFMES-AFDIL. Known for identifying the remains of soldiers from battlefields as far back as World War II and the Korean War, the lab had mastered techniques for working with degraded and ancient genetic material. Using a method known as hybridization capture, scientists at the lab delicately pulled out the surviving fragments of DNA from the old bones, like fishing threads from a decaying tapestry. Next-generation sequencing stitched those fragments into readable genetic profiles, scanning not just the Y chromosome, but mitochondrial DNA and over 95,000 nuclear SNPs, single nucleotide polymorphisms, each a genetic breadcrumb in a centuries-old trail. But technology alone couldn't close the loop. It needed a bridge to the present. That bridge came in the form of Samuel Walter Washington, the current owner of the Harewood estate and a living direct male line descendant of George Washington's brother, Samuel. His decision to offer his DNA became the spark that brought the past into focus. When his genetic profile was compared to the recovered remains, the results were decisive. Every marker aligned. The bones belonged to his ancestors, and through them, to Augustine Washington's line, the same line that had produced George. The Alpine ancestry twist. With the Washington Y chromosome now fully sequenced, scientists could finally trace the line backward, not just to colonial Virginia, but deep into prehistoric Europe. The results were unexpected. George Washington's paternal DNA belongs to a genetic haplogroup known as RU152, a lineage that first emerged nearly 4,500 years ago during the Bronze Age. Its origin is rooted in the highlands and river valleys of what is now Switzerland, northern Italy, and eastern France, regions once populated by early Celtic and Italic tribes. This wasn't merely a genetic footnote. RU152 is a marker of migration, a whisper from a time when metallurgy was new, tribal alliances were fluid, and identities were forged in oral tradition and iron. Archaeologists have found RU152 in remains from the Hallstatt and La Tène cultures, sophisticated societies that predated the Roman Empire and spread their influence from the Alps into the British Isles. These were the people who crafted ceremonial swords, built trade routes across mountain passes, and developed symbolic art that still survives on pottery shards and carved stone. In this context, Washington's lineage takes on new depth. His Y chromosome connects him not only to colonial America, but to the cultural and technological awakening of ancient Europe. This genetic echo travels from Bronze Age burial grounds to the Revolutionary War, suggesting that the man who shaped the birth of a modern democracy may have inherited the legacy of a world that shaped civilization itself. A royal parallel with a shocking contrast. Just 2 years before the Washington DNA breakthrough, another historical lineage unraveled in dramatic fashion. In 2022, scientists at the University of Leicester completed a full Y chromosome sequencing of King Richard III, whose skeletal remains had been discovered beneath a parking lot in England in 2012. Their goal was to verify the identity and confirm his connection to surviving male line descendants. But what they uncovered wasn't affirmation, it was rupture. The DNA from Richard's 500-year-old skeleton did not match the Y chromosomes of living relatives believed to descend from his paternal line. Somewhere between the 14th and 17th centuries, a false paternity event, known in genetic genealogy as a non-paternity event, had severed the line. A break that had gone unnoticed by history for centuries was suddenly exposed by science, rewriting not only the royal family tree, but shaking the perceived certainty of monarchical descent. The crown, it turned out, may have rested on the wrong head. Now contrast this with the Washington revelation. Unlike Richard III, George Washington's male line had remained genetically intact, stretching unbroken from 18th century Virginia back to Bronze Age Europe. The confirmation of this continuity wasn't just a scientific victory, it was a narrative triumph. In an age when DNA often dismantles myths, the Washington lineage held firm. The irony is striking. A crowned king's bloodline dissolved under scrutiny, while the genetic thread of a man who refused kingship endured. In that contrast lies a story not just of science, but of legacy, and the different ways power leaves its mark. The DNA web of history. As scientists studied George Washington's newly revealed genetic signature, they began noticing echoes, some in the most unexpected places. One of the most striking came from another American icon, Abraham Lincoln. Like Washington, Lincoln's Y chromosome belongs to the RU152 haplogroup. Despite being born nearly a century apart and under vastly different circumstances, Both presidents shared this same rare genetic lineage, a link that quietly unites the founder of the nation with the man who preserved it. But they're not alone. This Alpine haplogroup appears in a surprising range of figures across history. Among them are the House of Habsburg, whose dynastic reach shaped Europe for centuries, the Scottish poet Robert Burns, and even musician Johnny Cash. Each is a thread in the vast genetic tapestry woven through time, one that converges in places we least expect. However, genetics doesn't always follow straight lines. When researchers compared the DNA of Washington's historical and living descendants, they noticed something unusual. The relationships appeared one generation closer than the paper records suggested. The reason was pedigree collapse, a phenomenon common in colonial elite families, where cousin marriages compressed family trees, repeating ancestors and tightening kinship bonds. And then came one final twist. Among the samples from Lucy Payne Washington's line, scientists found a subtle trace of African ancestry. Though the Washington Y-chromosome is overwhelmingly European, this admixture entered the family tree through Lucy's side, intertwining America's racial and familial histories in ways the founders themselves likely never imagined, rewriting the past, strand by strand. What began as a question about one man's ancestry has grown into something far more expansive. George Washington's DNA didn't just confirm lineage, it reframed it. Through a single Y chromosome, the story of America's founding loops backward into Europe's tribal past, touches ancient migrations, and brushes against royalty and revolution alike. More importantly, it challenges the way we define historical truth. For centuries, ancestry was tied to names in dusty ledgers, inscriptions on stone, and family lore passed down in whispers. Now, it's etched in molecules. And unlike documents or memory, DNA doesn't bend to narrative. In the genetic signature of George Washington, we find not just a biological thread, but a deeper human connection, across borders, centuries, and identities. The past isn't frozen in place. It's living, evolving, and waiting to be found, not in grand monuments, but in the code we carry. For over 2 centuries, Washington's ancestry remained a sealed chapter. But with one strand of DNA, science didn't just open that chapter, it rewrote it. If this story moved you, subscribe for more untold histories, and share it with someone who still believes the past is set in stone.